Thanks for coming to Plexure, everyone. Welcome, as Michael said. I'm Vicky Avison, so I'm Principal Data Engineer at Plexure. I've been here just over 4 years. I'm based out of the UK, weirdly, but I've come over here for 2 weeks, and I'm going to talk about some very exciting stuff we're doing at the moment. So we've been through a big data platform transformation in the past, and we're on the cusp of the new dawn, which is moving from infrequent batch ingestion to near real-time streaming. So that's what I'm going to be talking about today. Yes. So just a bit of context, at Plexure, we ingest hundreds of millions of customer activities and transactions every single day from over 60 countries around the world. I have a picture. Yeah, if you don't know what we do, we're a mobile engagement company, so a very large global fast food organization, which you may have heard of. We do the technology that sits behind the mobile application for that. So if you're on the app and you're looking at an offer, or you're going to a store and you redeem an offer, or you're kind of part of the loyalty program and you're earning loyalty points, that's all Plexure that you're interacting with. From a data perspective, we're gathering data from all of that life cycle of the customer. So you're in all of these different places and we know about it, but in a good way, because then we can use that to fuel our personalization engine. So give people personalized offers based on what they like, and also kind of the people in the large fast food organization who work in marketing can tailor their marketing based on the analytics and stuff we provide to them on how these campaigns are going. So that's what we're doing from a data perspective. But we want to do this faster because we're not doing this as fast as we want to do. And we want to be able to respond to things faster. So what slows us down? So the first one, as I said, the way we're bringing data in currently and in the past is in kind of infrequent batches, so daily, a few times a day, that kind of thing. Some things are hourly. But the problem with this is we can only respond to things kind of hours or even days after they've actually happened, and we want to be more responsive and target people more in the moment. And also the analytics we're providing to marketers, they want that more frequently because, again, they want to be able to respond to things more quickly. So we just want to bring data in more often, which is fairly reasonable ask. But there's more things. It goes beyond actually how fast the data is coming in. There's operational issues. So actually making changes to our data ingestion pipelines is quite hard because one of the issues is evolving schemas is quite risky. So with our legacy pipelines, they're a bit vulnerable to failures. So I know things like removing columns, changing data types, they can seem fairly innocuous to the people making those changes, but then it kind of flows downstream into the data platform and then something just blows up because it was relying on that. So this is one of the problems we have. So when we're doing a project, it can either cause a downstream impact, or we need to have lots of discussions and make sure we're all happy. And it's just quite a big operational cost. And on a similar kind of topic, bringing in new data is actually a significant piece of work. So we want to ingest a new data set. There's kind of a team who kind of work on the APIs for that. We need to work with them, agree schemas, and do lots of chatting. And we need to build a data engineering pipeline. It's quite a lot. And we really want to be able to kind of move faster, bring more data in faster, evolve things faster, and also just have the data coming in faster. So that is the dream. So this is kind of our rough, high level solution that we've landed on. So there's actually a kind of well-established pattern for streaming ingestion that involves a streaming platform we're using Azure Event Hubs, but also Kafka, what we heard of. You can have managed Kafka or self-hosted Kafka. In AWS, you've got Kinesis. Using Avro serialization, so I don't know if you've heard of Avro serialization, but it's a serialization format for serializing those messages, and then a schema registry for kind of storing all those schemas for those Avro messages. The schema registry is kind of key to all of this. So it's a great centralized repository of all the types of events we've got flowing through our system. And it's kind of technology agnostic because we as consumers, we're in Databricks, we're using Delta Live Tables, PySpark. Our producers are kind of all in .NET on the API side. So the schema registry doesn't care about that. It's like something that can talk to both sides, which is very handy. The key thing it does for us as well is it validates schemas. When we evolve schemas, it validates that those evolutions are compatible and they're not going to break things downstream. So you can set compatibility modes on the schema registry so that, for example, if someone wanted to change the type of a field from a string to an int or something that could be lossy, the schema registry would reject that and go, no, that's not allowed. So in our setup, so we've got our producers. So we've got our app developers, for want of a better of a word. They're our producer, the people who develop the producer code. They go in, they write all of that, and then there's a CI/CD process there. As part of that process, that will register a schema in our schema registry. If there's any problems with that, the schema registry doesn't like it, says it's not compatible, that will fail at that point. So basically that code will never make it into production. It fails at CI/CD time, which is really handy. If all is good, then that code gets deployed to production. If for any reason something has gone wrong in that process and that code has made it, but it doesn't match the latest schema in the schema registry, that will then fail at that point. So again, that's like another safeguard for us. But if all goes well, we get on the Event Hub just the schema ID. So each schema in the registry has a unique ID identifying it. We get that and the serialized data, but the schema itself lives in the registry. And then on our side, we'll fetch the latest schema and then we'll use that. Well, we'll fetch the actual schema for the event, show that in a bit, and use that to deserialize the event. And then we pump that into a table in Databricks. So that's sort of a high level overview. I do have kind of a deep dive with lots of code, but I did just like before I start, I was keen to do a bit of a show of hands, like how many people have experience with Spark structured streaming? Not that many. Okay, but that's all right. I might skim through this a little bit because there is quite a lot of code in here. But for those of you that don't know, Live Tables is a Databricks product for building pipelines. It's kind of wraps around Spark structured streaming, which I don't know. Do people use PySpark? Yeah. So yeah, Spark structured streaming. It's just PySpark, but you kind of deal with data frames, but it handles all the streaming stuff for you. So hopefully some stuff should make sense, but yes. Hopefully show that, but we'll see. There is a demo. We'll see how we go. Although I'm not sure I've actually got the schema evolution. Well, we'll figure it out. I will hopefully answer that. If I haven't, ask me again. Yeah, cool. Alrighty. So ignoring schema registry for now, I was just going to show some code of like how you just deserialize Avro using PySpark. So I've got an example where we've just got a static schema that doesn't change. The code is really simple. For those of you that don't know structured streaming, which was, I think, maybe everyone, yeah, it's really simple syntax. It's just read stream. Event hubs, actually, you can read it like it's Kafka because it has like a Kafka endpoint, which makes it really easy to use. So yeah, you just read Kafka, and then we've got this from Avro function that we can use. We pass it the schema, and then value is the name of the column on the data frame. It's literally as easy as that. Yes, how do we then do schema evolution? So again, ignoring schema registry. Got two versions of the schema now. It does get a bit more complicated here. So we've got two versions of our schema. From Avro is a bit awkward because you need to pass the exact schema that the record was serialized with. So this assumes we have a column on our data frame that says what the schema version is, but we need to split that into multiple data frames, use from Avro with the actual schema for that version of the schema, and then union them back together. The union happens down here. By the way, as everyone is interested in like looking into this in more detail, I am writing a blog, which is not yet published, but I'll put a link to our like general company blog at the end, and you can listen for it. Yeah, because I will be putting all these snippets on there. Yeah, cool. So then we go into fetching schemas from the schema registry. So I haven't talked. There are different implementations of Schema Registry. This is the Azure one. The more famous one and more easy to integrate with and much prettier is Confluent, and that is actually what we are using internally. But this is a nice story with the Azure one because it means you don't have to get another vendor in. It's very handy. But anyway, this is a nice little screenshot for you. So schemas are organized into schema groups, and within the schema groups you have different schemas. So here we've got two types of events. And you've got a schema and they're versioned. It's all grand. So how does that look? All right. Yes. So there is a Python client for the schema registry, which you're like, yay, great. But actually it has very limited support for the API. You can fetch a schema, but you have to know the exact schema ID or the name of the schema and the version. And unfortunately, what we want to do is actually get all the versions. So had to call the REST API directly, but that's all good. So we can get all the schema versions, calling the REST API, and then we can get the actual schemas using the client. And then we put it all together. So this is my client that I just wrote. Yeah, we get all our schemas. This is all the different versions of the schemas. This is kind of like what we had on the non-schema registry example where we'd created a map of version to schema. Right, this is Delta Live table syntax. So the at dl2.table is we're saying this is a table we want to produce in our Databricks platform. Here we are, we're doing our reading Kafka again. We're extracting the headers from that because the headers is where we get the schema ID from. So this is just the schema ID is in like average/binary plus schema ID. So we're just extracting that. Nice. So then we have the schema ID. Next one, we want to deserialize the messages. We want to get the later schema. Yep, we want to read our raw table. Then the thing is, because we've only got the schema ID at this point, and we want to do that splitting by version that we showed on the last one, we need to get the version on this. So we create a little data frame based on our schemas that we've just looked up. We join that to our incoming data frame, and then we do exactly what we did before using these schemas that we've looked up on the registry. That's all good. All right, and finally, schema evolution of events. So what happens when the schema actually changes? So we've fetched our schemas, but we do this at initialization time of the pipeline. So while the pipeline's running, if the schema changes, or we get a new schema, we kind of need to force a restart of the pipeline. So this runs again and we reinitialize it. This is kind of how other Spark things that do schema evolution work. I don't know if anyone's used autoloader in Databricks, but that's kind of a similar thing. So to force the restart, we are using Delta Live Tables expectations, but there's obviously ways of doing that in open source Spark as well. But this basically looks for whether we've seen that schema ID before. If we haven't seen the schema ID before, we go fail, it'll fail, and the whole pipeline will restart. And then we'll start processing data with the new schema. And because we've got the compatibility guarantees on our schema registry, then we kind of know it's going to be compatible, and we're happy pumping that into our Delta Lake table in Databricks, and that'll all evolve nicely. Cool. Yes, we're done. All right, so the next thing we wanted to do is take this a bit further and make it really, really easy to publish new data sets. So what we really want to be is we want to be in a position where a team can produce new data sets to our event hub, and our Delta Live Tables pipeline will just magically pick that up and produce a table in our data platform without actually there needing to be an engineering project, be like heaps and heaps of discussion and work. I mean, we probably want to discuss before we move to production, blah, 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 blah. But at least for development, they can start producing and we can start building that out. So this is the dream. Actually, just a couple of tweaks to our code to make this happen. We just need to add a couple more functions to our lovely client. Instead of getting just the versions of a schema for a specific schema, we want to get all the schemas in our schema group. So that is what this is doing. And then there's a really fun thing called DLT metaprogramming, which allows us to kind of dynamically create Delta Live tables outputs based on iterating through a loop. So what we're doing here, we're getting all our schemas, we're getting all the IDs, and we're iterating through all the schema names that we've seen. So I think way back, I had a picture. There was like 2 types of events that would be iterating through those 2. For each of those, we're creating a table. Yeah, and we're basically doing the same thing that we did before, but instead of for one table, we're just doing it for multiple. So this is all that same stuff. And then we're done. So I do have a demo, which I'm praying to the demo gods will actually work. I did it a few times today and it worked, and then it didn't work, and then it worked, and then it worked. So we're hoping. We're just really hoping. Right, okay. Where are we? Okay. I think I might start this first. That'll be good. So this is my data live tables pipeline. I should have the code somewhere. Here we go. Ah, what did that do? No. Sorry. What? I just closed Chrome. I don't know how that happened. Oh dear, it's going well. Demo cards. No. All right, it's fine. It's fine. Right, this is starting. Oh, good. Oh, I tell you what I can do. I can click on here. Yes. Right. Me too. Where are we? Alrighty. We're good. Oh my god, what are you doing? Sorry. I should have probably practiced this anyway. Okay. Right, my code is here. I can't even find the maximize button now. It's all looking all weird. Anyway. This is my data live tables pipeline, so this is kind of what I've just worked through, so don't need to look at that. But I'm just proving it's real. It's a real thing. It's what we just showed. Awesome. Where did everything else just go? Oh my goodness. Here we go. All right, so that's what we did. So where's the pipeline gone? Oh my god. Life just hates me. All right, okay. Here is my pipeline running. We're just going to go with that. Yeah, we can see it. Cool, happy days. So at the moment, this isn't really doing very much. It's not ingesting any data, but this is just my raw data. I'm going to start sending some events. So I have a publisher here that will publish some events. It's kind of like generates random records that are either of type sales or they're of type clickstream events. But I will pick one and start sending some and hope that it works. Oh, the other thing I was going to show before we start, this is my schema registry. It's got nothing in it. It sounds like a magic trick. I'm like, it's got nothing in it, and then it will have something in it, but it's all good. Cool. Right, I'm going to run all of this. And then we should start getting some events and some schemas, and it will be very exciting. Yes, please work. There we go. Right. Computer's just spinning up. Just talk more. Yeah. If you're interested, this data actually comes from there's some there's the thing called Databricks Marketplace where you can get data sets you can use. There's one, I think Databricks provide it. It's clickstream data, sample data, and I'm just kind of ripping random events from that. Saved me creating some myself. All right, I think we're running. Yeah, it's sending some events. So we should start to see the schema registry update. Because I've got auto register on here. Ah, here we go. Sales. Yay. So far, so good. Oh, this is where. Yeah, so we can see this is all nice. Like we can see our schema. We're on version 1. Happy days. Right. And then wherever my pipeline's gone, this should. It's failed. We like this. So what we want to see is this fail. I want to open this. And it should restart. There's a bit of a lag sometimes of it restarting, but hopefully by the time this is loaded. Oh, we're running again. Are we? Oh no, it failed again. No, wait, was this the original one? Yeah, this is just the original one. So it should restart itself. But this is the bit that wasn't working earlier, so, you know. Oh no, it has. Yeah, I've got a little thing that like listens to that and then restarts it. Yeah, magic. No, actually, if you run this in batch mode, not streaming mode, so I'm running this in streaming mode. If you run it in batch, it will like kill itself and restart. But because I'm running in streaming, because I thought that would be more cool. Yeah, it doesn't restart. So I have to have a listener that kills it and restarts it. Yeah, so that like it kind of stops it where it was, and then it because it's streaming, it knows where it got to, so it didn't get anywhere. So then it should start processing some stuff now. Yay! So we saw 4 events come into raw. Those are the ones I sent, and then we should see them flow through. Oh yeah, 5. I sent 5. Yeah, so there we go. That is, we have some events flowing. I can throw some more in. It's just the wrong notebook. Not that one. Not that one. This one. I can send some more, just like send another 2, and we should see those flow through with no problems, because I haven't done anything. Yes. So we should go on Democrats. Yay! Got 7 through here. And then that should, yay, 7. Okay, we're seeing them flowing through. Cool. So the interesting bit is then we start to send a different type of event. So we've got some doing this one hand, so it's really slow. I have a type of event called clickstream events. Cool. I'll just send 2 of these. And then what we should see happen is another schema get registered in the registry. More events get sent. I've lost my registry, that's on different. That's going all right so far. Okay. Here we go. Yeah, so you see different schema, different stuff in here. All fun. Where is our pipelines? We should now see this. Yeah, it's failed again. It should now restart itself. Yes, it's stopping. Yay. Okay. And then this is where the magic happens. It should show up with the new type of event. Yes. So I don't actually have an example set up for evolving the schema. That was a bit of an oversight, but it would, the same kind of thing would happen. You would send a new version of the schema, and it would fail and restart, and it would start processing with a new schema. I can show you the tables as well once this is done. Yes, fortunately, that's not a situation we should find ourselves in. But yeah, and we don't send absolutely everything to one. We kind of have it split out by kind of domain. So it is kind of contained. But yeah, obviously it's a concern because we're hitting the APIs and we're reading that all into memory, so it needs to be reasonable. But yes, we have thought about it. It's not a situation we expect to find ourselves in. As of yet. So yeah, you can see it picked up on new type of event. And we've now got 2 of those, and then I could fire some of the old one back and we would see that flow through, which would be fun. And then I think let's demo out. Then hopefully this won't fail this time. That's the dream. Yeah. Nice. So that's we have that. So the idea is someone could start sending us new type of event and we just start processing like magic. And yeah, as I said, the actual schema evolution should all work really nicely as well. Just one more thing. I think I had it open in here. Oh, I think I did. Yeah. We've got all our tables in here. I did have it filled just to show that, but I don't know where that's gone. Yeah, we've got our raw data. If anyone is interested in seeing what the raw data looks like, it's just serialized bytes. Yeah, so this is what your like serialized Avro record looks like if you're interested. Just bytes, just 1 bytes. Yeah, not much going on in here, but then we process it into our actual tables. Awesome. Yes. So it looks like actual data. Yay, yay. Okay. That's I'm done. I think that's me. That was my demo. I think I just went, yes, thanks for listening to our journey of streaming data.